my name is Heidi.
And my name is Taya.
And today we'll be discussing dynamic topics that can be applied to the sport of baseball.
The first topic is the impact between the ball and the bat. The second topic is the conservation of linear momentum.
Before we start, let's talk about impact forces.
An impact force is a contact force between two surfaces that collide. An impact is a subtopic of impulse momentum, which is force over a period of time.
This impact graph shows that an impact force is a very large amount of force over a very small amount of time. So let's go out to the court to see impact forces in action.
Let's discuss what's happening here. To fully describe what's going on, we need a free body diagram and a start and end impact diagram. Let's take a look at our free body diagram. In our free body diagram, we've drawn it in the middle of the impact so we can have the greatest amount of forces. MA is the mass of our bat, and MB is the mass of the ball. The forces that we have in our diagram include the mass of the bat, the mass of the ball. We also have the force of the hand applied to the bat, but for the sake of simplifying this problem, we're ignoring it. Finally, we have our impact force. In impact problems, we want to avoid this impact force, so we've drawn our y-axis in the direction of this impact force. Depending on the position of the ball and the bat, the direction of our impact force can change.
Moving on to our mass velocity diagram, which shows the start and end of the impact over a very small amount of time. For this problem, we're assuming that the bat is swung up at an angle θ1 and the ball is coming down at an angle θ2. So once the impact occurs, the impact force causes the ball to go backwards into the respective x and y components based on our axes. The impact force has a very small effect on the bat because the force of the hand is great enough to overcome that impact force, so the bat continues its circular path. So like what was mentioned earlier, the path of the ball will depend on the direction in which the bat is swung, as well as the position of the contacting surfaces. So here we're just assuming that the bat is swung horizontally. So as the ball hits the bat at an angle θ0, the impact force will cause the ball to go straight back. In this case, the ball contacts the bat below the center of mass of the bat, so the impact force causes the ball to go down at the angle θ. And for this case, would cause the batter to get a strike because the batter swings too low and the bat hits the ball. It hits the bottom of the ball, causing the ball to go backwards.
Now let's see what it would look like if we wanted to solve for some of our values. First, we have a conservation of momentum in the y direction for the bat and the ball. We have initial momentum equal to the final momentum. For the initial momentum of the bat, we have MA VA1 sine θ1 minus MB VB1 sine θ2. This is a negative for the ball because the ball goes in the negative y direction. Next, we set that equal to MA VA2 sine θ1 plus MB VB2 in the y direction. Now, the same applies for conservation of momentum in the x direction. Finally, we have coefficient restitution. Coefficient restitution measures how much kinetic energy remains after the impact, and is denoted by E. E equals V separation over V approach. Now, in this case, we only care about the velocities in the y direction because that's the same direction our impact is in. Now, looking at V separation, there's a minus sign here because the velocities at the end go in the same direction. In this case, for the approach, there's a plus sign because the velocities go in opposite directions.
With this video, we are able to understand the inner workings of baseball using dynamic concepts we learned in class.